The next time you're waiting at your gate, look out the terminal window. Most people watch the massive engines or the sweep of the wings, but the hardware resting on the pavement is what keeps the airframe intact. Every landing is a controlled collision with the Earth. If the wheels beneath that 100-ton machine fail to manage the energy, the aircraft destroys itself. To understand how planes routinely survive these impact forces, we need to look past the fuselage and learn to read the runway like an expert plane spotter. If you want to uncover the engineering details keeping you safe in the air, hit that like button and subscribe. The landing gear stands as the only line of defense between a fragile aluminum shell and the unforgiving concrete. Identifying an aircraft's configuration starts with the wheels. You're looking for two primary setups: the older conventional or tailwheel gear and the modern tricycle gear. On early designs, two large wheels sat up front, with a small wheel dragging in the back. This tilted the nose high into the air, providing necessary ground clearance for the massive propellers used on older, lower-powered engines. This shape has an inherent physics flaw. Because the center of gravity sits behind the main wheels, the plane is unstable on the ground. A slight crosswind can send the heavy tail whipping around to the front in a dangerous spin-out called a ground loop. Engineers eventually flipped this arrangement to create the tricycle gear. As seen on this TWA constellation, the stance is level, with a single wheel under the nose and the main gear placed back under the wings. Shifting the center of gravity ahead of the main gear forces the plane to track straight, eliminating ground loops. This layout allows pilots to apply maximum braking without tipping forward, while offering a clear view of the taxiway ahead. The placement of that smallest wheel is a visual record of how aviation solved its most persistent stability problems. Beyond the external shape, there is the question of how a hollow metal leg survives the kinetic energy of touching down at high speed. The solution is the oleo-pneumatic shockstet. It's a self-contained hydraulic unit using two chambers, compressed nitrogen gas at the top to act as a spring, and hydraulic fluid at the bottom. The moment the tires hit the runway, the aircraft's weight forces the lower piston upward, which compresses the internal gases. To absorb the shock, the hydraulic fluid is forced through a tiny opening. A tapered metering pin partially blocks this hole, controlling the flow. Forcing thick fluid through such a narrow space creates intense friction, converting kinetic energy into thermal energy, dissipated as heat. This fluid friction acts as a thermal converter. Without it, the raw shock wave of landing would travel directly into the airframe and risk structural failure. On the tarmac, you can often spot bright red ribbons hanging from the wheels of parked aircraft. These mark the ground locks. They are physical metal pins inserted into the retraction joints to ensure the gear cannot fold inward while the plane is being serviced. Pilots verify the gear's status from the cockpit. Before landing, they look for 3 green lights on the panel, which indicate that every gear assembly is down and mechanically locked. A final safeguard is the squat switch or safety switch. It's an electromagnetic sensor on the gear assembly that detects when the strut is compressed by the plane's weight. While the plane is on the ground, the compressed strut keeps this switch open, which triggers a locking pin in the cockpit. This physically prevents the pilot from moving the gear handle to the retract position while rolling. A successful arrival always depends on this synchronized loop of hydraulic resistance, electronic proximity sensors, and physical pins. The tricycle gear, supported by heat-dissipating struts and redundant safety switches, has moved aviation away from the stability risks of the past to create a reliable global standard. Look out the terminal window now, and those rubber tires represent a century of solved physics problems, protecting the passengers inside. To keep looking closer at the engineering details hidden in plain sight, make sure to like and subscribe.